Hi there, welcome to EduretiX, where we make your high school life simple. I'm Aniket and I'm here with the part 3 of the Kinematics practice series for AP Physics 1 and GCSE papers. In this video, we're going to do moderate difficulty questions using equations of motion, projectile motion, and a few other concepts. So like I've always advised, whenever you see the new question, pause the video, try it yourself, and then only look at our solution. Let's begin. A projectile is launched at a certain angle. After 4 seconds, it hits the top of a building 500 meters away. The height of the building is 50 meters. The projectile was launched at an angle of. Okay, so they're asking the launch angle of the projectile. So there would be an initial velocity, like this here is the projectile. It'll be launched with an initial velocity, let's say u, at an angle with the horizontal theta. Okay, so they're asking for this angle theta, and they've given us the two displacements, the vertical displacement in the form of the height of the building and the horizontal displacement in terms of the distance of the building from the point of launch. Okay, so the distance of the building from the point of launch is 500 meters and the height at which it strikes the building, this is 50 meters. Okay, so the horizontal velocity is going to be u cos theta and the vertical one u sin theta. We'll write two equations for both the displacements. So the vertical one, there would be an acceleration of negative g downwards. So let's say s 500, oh no, not 500 but 50, yeah, 50 is equal to ut, so u sin theta t, and t is given to be 4 seconds, so we can write that as 4 u sin theta t minus half 10 t squared is 16. This is the first equation. Simplify it, so u sin theta 4 u sin theta, then here it's going to be 2 times 5 and 80, 130 is equal to 4 u sin theta. This we get from the vertical displacement, first equation. Okay, second one from the horizontal displacement, no acceleration, so simple, 500 is equal to u cos theta t, 4 u cos theta. Okay, now there are two variables, theta is also a variable, u is also unknown. So how are we gonna find out? So the easiest way for that is, it's a trick also, just divide both the equations, because you can see sin theta and cos theta, the 4 u's would cancel. Okay, so we can write 130 is equal to 4 u sin theta. Now divide them both, 4u and 4u cancel, sin theta or cos theta is tan theta is equal to 130 over 500, 13 over 50. Now we'll do the tan inverse of 13 over 50. So the tan inverse is going to be, through your calculators you can check, it will be 14 degrees, approximately 14 degrees. So that's the answer, 14 degrees. So this trick is very useful. Like you can see that there were two variables, but upon division, one variable got cancelled and the trigonometric ratios gave us tan theta. And anyways, we can get the angle from any trigonometric ratio. It's not necessary that we need to figure out sin theta only or cos theta only. Okay, let's move on to the next question. This is an interesting one. Okay, a woman stands on the bank of a frozen lake with a dog by her side. Okay, so let's say here is a frozen lake. The woman is standing here with her dog. Let me mark the dog in blue. Okay, so she's standing on one bank, on one side of the lake basically, with the dog by her side. She slides the bone across the ice at a speed of 3 meters per second, and at the same instant the dog begins to chase the bone. Okay, the woman slides the bone through the ice, okay, across the ice, and the dog starts in the direction of the bone, starts chasing it. The bone slows down with a deceleration of 0.4 meters per second square, and the dog chases it with an acceleration of 0.6 meters per second square. How far out from the bank does the dog catch up with the bone? Okay, so the bone has its motion this side, dog is also chasing. Let's write the parameters of motion. So at a speed, so initial speed of the bone is 3 meters per second and it's decelerating at 0.4 meters per second square, so negative. The dog starts from rest and it's accelerating at 0.6 meters per second square. Okay, now we don't know the time at which they catch up. We don't know the distance from this bank, from this side where they catch up, so we need to check those cases. Okay, for the event that they catch up, for that to happen, the displacements must be equal. Okay, so they're like the final positions must be equal. So let's write that. So S, the displacement for the bone SB, is equal to UT 3t minus half 0.4 t squared. Okay, and then okay, so this simplified would be 3t minus 0.2 t squared. This is bone. Now for SD, dog, initial UT is 0, half G 0.6 t squared. Okay, so this goes on to be 0.3 t squared. Both these displacements or positions must be equal. So let's write that. Let's solve for equality here. Okay. So SB would be equal to SD. That is 0.3 t square is equal to 3t minus 0.2 t squared. This goes on to be 0.2 t squared is goes on this side. That's 0.5 t squared is equal to 3t. So t is basically 3 over 0.5, which is 6 seconds. There would be two values of t from here. It's a quadratic equation. One value would be 0. T is equal to 0. So that does not suffice. At t is equal to 0, yes, they were at the same point, the bone and the dog. But after throwing, we need to find the next time interval when they're at the same position. So t is equal to 6 seconds. After 6 seconds, they're going to catch up. Now, how far out from the bank? That can be calculated. So SD, we can use directly this one, the displacement of the dog, is 0.3 t squared. So 0.3 times 36. 6 squared is 36. This is going to be 10.8. So 10.8 meters and the dog catches up with the bone. Okay. An interesting thing to figure out would be, does the bone come to rest at that point? Let's check. So let's see how much time does the bone take to come to rest from the initial position. So initially it was 3 meters per second. It's decelerating at 0.4 meters per second square. So V0, V, that is 0, is equal to U, 3 meters per second, minus 0.4 T. V is equal to U plus 80. That's what we're using to find out the time interval for the final velocity to become 0. So this is going to be equal to 3 over 0.4 or 30 over 4, which is 7.5 seconds. So the bone does not come to rest when the dog catches up with it. The dog catches up with it in 6 seconds. The bone comes to rest in 7.5 seconds. But before coming to rest, it would already be taken or eaten by the dog. Okay. Let's go ahead to the next one. A cyclist travels from A to B, a distance of 240 meters. He passes A at 12 meters per second, maintains the speed for as long as he can, and then brakes so that he comes to a stop at B. If the maximum deceleration he can achieve when braking is 3 meters per second square, what is the least time in which he can get from A to B? Okay. This question for sure looks a bit different, yeah. But let's see if it's really that difficult. So it's saying that there's this distance of 240 meters from A to B. Okay. The cyclist crosses A at 12 meters per second. He must have been moving before A as well. Okay. He crosses at 12 meters per second and maintains the speed for as long as he can and then brakes. So naturally, to reach in the least time, the question is saying that he is breaking the journey into two parts. One part is moving at constant speed. The other part is braking. So for the least time, we would naturally want that the cyclist moves with the constant speed for as long as he can and brakes for the minimum time. Okay, for the least time he brakes. So they've given the maximum deceleration he can achieve is 3 meters per second square, and in that deceleration he has to go to zero velocity at B. Zero velocity at B. So what's the least distance required or the least time required to get a velocity of 12 meters per second to 0 meters per second, given that the maximum deceleration is 3 meters per second square. That means, what does this mean, 3 meters per second square? That means every second the velocity is going to decrease by 3 meters per second. So it was 12 meters per second. It will decrease by 3 meters per second every second. That means it will take 4 seconds, because 3 times 4 is 12. So in 4 seconds, the cyclist will be able to come from 12 meters per second to 0 meters per second and stop at B. That means we'll only give the braking time as 4 seconds. Rest of the time, he or she will be moving at constant speed. So let's write that. So T braking, TB, is equal to 4 seconds. Okay. Let's say he or she brakes at X meters from B. So this remaining 240 minus X is covered at 12 meters per second. Okay. So let's write this 240 minus X. We'll write the motion equation for this. This X, that is the braking distance, that can be figured out directly using the third equation of motion. So X is equal to UT. Initially it was 12 meters per second here as well. So 12, since he was moving constant speed, 12 times 4, that's the braking time, minus half A is 3, T squared, 4 times 4 is 16. Okay, so 2 times 8, 12 times 4 is 48, minus 24 is 24 meters. So X is 24 meters. What is 240 minus X? 216 meters the cyclist moved at constant speed. So what time was taken? Time is equal to distance upon speed, 216 over 12. 12 times 1 is 12, and then we have 96. 12 times 8 is 96. 18 seconds. So the minimum time becomes 18 plus 4. 22 seconds is the minimum time in which the cyclist can complete this journey from A to B. Okay, decelerating for the least amount of time. Okay, so I hope this question is clear. So this is a culmination of our AP Physics and GCC Physics videos on kinematics. Okay, and this much practice would be really enough and helpful for these two tests. Now the further parts coming in this series would be aimed at the higher level kinematics, that is A level, and the exam similar to A level. So keep practicing. If there are any doubts, post in the comments or reach out to me directly by email. Okay, and like, share, and subscribe to the channel so that you keep getting new content, new practice content. Okay, thanks.